right, got one classwork problem for you, a complex equation I need you to solve. Take just a few moments to solve this, and then we will take a look at the homework that you did. Mason and Genesis, when you're finished, just come around this way and put it on my desk, if you would, please. You have 30 seconds longer to finish up the classwork, and then we'll take a look at it together. Or maybe you don't need 30 more seconds. Tell you what, if you need just a little bit more time and you're watching on YouTube, go ahead and pause the video there. But let's go ahead and take a look at this together. What do we do first? Kind of walk me through here, Quentin.
First, you would distribute the 3 and the I.
Good. Distribute to clear the parentheses out to get
5y plus 3 plus 3ix equals 2x plus iy plus 11i.
Good, and then it's a y, not an x. All right, then what, Jamie?
Then we make 2 separate equations, one for real and one for the imaginary.
All right, what's your real equation?
5y plus 3 equals 2x.
And the imaginary.
3ix equals iy plus 11i.
All right, Quentin, now what?
Cancel the i's in the imaginary equation.
To get?
3x equals y plus 11.
All right. Now what, Jamie?
Now we can get to where either the y's or the x's cancel.
Okay.
That way.
All right, we could do that. So.
Then we'll rewrite the equations for them to line up, and they'll be negative 2x plus 5y equals negative 3. And the other equation will be 3x negative y equals 11.
Okay.
And we multiply 5 on the bottom equation to get 15x negative 5y equals 55. And then we cancel the 5 y's, and it leaves us with 13x equals 52, and x equals 4.
All right, from there then, let's come back to one of these two equations to plug in the 4, top or bottom?
Top.
Top, thanks, sir.
And it would equal an a on one side. Then we have to subtract 3 and get 5.
So 5y equals 5.
Right, and y equals 1.
Y equals 1. So there's our answer, x for 4, y for 1. Did you get the same answers? Did you do it the same way, or did you do the substitution? You went ahead and did it this way. If you had done substitution, probably ditching the 11 overs of 3x negative 11 equals y. substitute that in right here for the y to get, let's see, it'll be 15x, negative 55 plus 3 equals 2x. Would have ended up getting to a very similar point with the 13x equaling 52x equals 4. Plug the 4 in here, and that's where you get your y equals 1. All right, questions on the complex equations, or do we feel pretty good on those? All right, let's take a look at the complex numbers then. And we said there's two forms of a complex number. What are those two forms, Jamie?
The standard form and the Trig form.
What is the standard form of a complex number, Quentin?
A plus bi.
What about the trig form, Quentin?
R times cosine theta plus y sine theta.
Good. How do we go from the standard into the trig? How do I get from a's and b's to r's and thetas, Jamie?
With the r, you take the square root of the a squared plus b squared.
All right, and then for the theta,
You take the arctangent of b over a.
but remember I said you've got to account for what on the theta class?
Quadrant.
The quadrant that you're in. Now, what if I wanted to go from the trig form into the standard form, take it ugly and make it look simpler? What would I need to do for that, Quentin?
You would have to find the reference angle, and then you would distribute.
Yeah, basically, if these are special angles, right, you'd figure out what the sine and cosine are based on reference angle, quadrant, ASTC, all that kind of stuff, and you distribute. If they're not special angles, you use a calculator and you'd still distribute. So no special formulas needed, just distribute to go from there. And that's what your homework was on. You had page 183, numbers 5 through 19, the odd. Page 183, 5 to 19, the odd. And number 5, you had 1 plus I. When you went to find the r, what did you get the r value to be, Jamie?
1.
Ooh. What is a?
1.
And when you square it, you get?
1.
What's b?
1.
1. It's not 0. So when you square it, you get
1.
1. And when you add, you get the square root of?
2.
2. Yeah, okay. And then for the theta, I'm interested then, when you took the arctangent of b over a, did you say 0 over 1?
No, I had it in the thing 1 plus 1 after squaring them, but then I forgot I still did 1. So
Gotcha. Okay, so you did have the b value 1 over the a value 1, which
Right.
gave you
45.
45 degrees, and it is quadrant
1.
1, so we don't need to do anything with that angle. I'll just write my trig form number.
Square root of 2 times 20 cosine 45 degrees plus I sine 45 degrees.
Good. Questions on that? All right. Number 7, we had negative 4 plus 4i. What did you end up with for your r value here, Quentin?
Square root of 32.
All right, that's true, but I can reduce that.
Yeah. 16 and 2. So 4 times square root of 2.
There we go. And then what about the theta? What did you get when you took the arctangent of 4 over 4?
Probably 45.
Well, you're considering 1 over 1 was 45, 4 over 4 is going to be 45 too, isn't it? But it's not 45, because this isn't quadrant 1, this is quadrant 2. So 45 is more of a reference angle. I need to come up 45 from the 180 to get
135.
135. So my answer should have been
4 times square root of 2. Cosine 135 plus I sine 135.
There we go. Again, we haven't seen reducible radicals for a while, so this is a good opportunity to see one that does reduce down. Just a reminder to reduce, and again, just be careful on the work there on the angle. Number 9, we had negative 8, negative 8i squared of 3. We needed to find the r. Now, Jamie, I'm going to go ahead and work this one out with you. When we square the a, we get?
We get 64.
When we square the b, b is actually 8 times the square root of 3.
Mm-hmm.
The I just happens to be written in the middle of it, but it's all b. So you have to square the 8
64.
and the square root of 3,
3.
and multiply the 64 and 3 to get?
Oh, multiply. I did add.
Okay. Because it's multiplied, the 8 times the square root of 3, so 64 times 3
192.
is 192, which when we add that to the 64, it gives us the square root of?
Let's see. 256.
Ooh, and that's something we can take the square root of. Not sure if you remember back that far.
No, 16.
16. It has been a couple more, an extra year for you over what it's been for Quentin there. But yeah, square root of 256 is 16. So my r came out evenly, though that doesn't affect the theta. That's the saving grace. Your theta could be correct anyway. Again, ignore the negatives. Just put an 8 square root of 3 and 8. Or if you wanted, you could even cancel and just say arctangent of square root of 3
16.
comes out to 60 degrees. But we're actually in quadrant
3.
3. So instead of saying 60, I'm going to say
150? Right.
quadrant 3. So we're going to start at 180, go 60 more.
Oh, 240.
240. And we end up with a 16 times the cosine 240 degrees plus I times the sine of 240 degrees. How many have that?
I guess I have to remember those quadrants.
Gotta remember the quadrants, okay. Did you get the angle?
The angle, I kept the 60. I also
You kept the
didn't
60,
know
and then we had some trouble with the R there.
Yeah.
Right? Does it make sense now?
Mm-hmm.
All right, and then number 11, we had 6 negative 6I. What did you get for the R value here, Quentin?
6 times square root of 2.
Good. This came out to the square root of 72, and Quentin caught it this time, 6 times the square root of 2. The theta, when you take the arctangent of the 6/6, it becomes,
45.
but we're in quadrant 4, so we're actually going to say
315.
315, so our answer should have been
6 times square root of 2 times cosine 315 plus I times 315.
And it happened here that all of our angles on the homework were special angles. That won't always be the case necessarily. Do we want to practice another one like these?
Yeah.
Okay, let's do another one. Do you want to do one with a radical in it, or you say, I think I know how to handle the radical, so just give me another one in general?
No, one in general.
Just another one in general? All right, so let's say we've got negative 3, negative 7I. Let me give you one with a radical as well. Let's say we've got negative 4 plus the square root of negative 5. Actually, let's do 2 times the square root of negative 5. Finished. right, let's see how we did here. First of all, let me get my calculator. That would help. We had to take the square root of the 9 plus 49, which is the square root of 58, which does not reduce. So we'll just go with square root of 58 times the cosine of, we need to take the arctangent now of 7/3, which is 66.801, blah, blah, blah. But we're in quadrant 3. So we're going to add 180 to that. And we're going to call it 246.8 degrees plus I times the sine of 246.8 degrees. Remember, we'll go 1 decimal on the angles in here. How'd we do? Good?
Quadrant.
Forgot the quadrant again?
Yeah.
Okay, all right. As long as we learn from it. All right, here, it's not actually written in imaginary format yet. We need to pull out the I. So -4 plus 2I squared of 5. That's not really a big deal, but, you know, there we go. All right, so then we're going to take the R value. We're going to take the square root of the 16 plus 4 times 5, which is 20. Which gives me the square root of 36, which actually comes out rationally to be 6. I wish I could say, wasn't that genius planning on my part, but I made it up off the top of my head and it just happened to work out. So I'll be honest and own, sometimes you get lucky in life. All right, then we have to take the arctangent of the B, which is the 2 square root of 5 over the A, which is the 4. If you wanted to, you could reduce and call it square root of 5 over 2. And so the square root of 5 divided by the 2 and take the arctangent comes to a 48.18 degree angle, but we're in quadrant 2, so we're going to subtract that from 180, and we actually get 131.8 degrees, plus I times the sine of 131.8 degrees. How'd we do? Got it?
So we're gonna have the 4 digits for the answer.
Well, 1 decimal.
Yeah,
It's kind of just what, just 1 decimal, just because nearest whole angle is a little too rounded for my liking, so I like to show, plus show it doesn't work out evenly. So 1 decimal place kind of shows it's not necessarily an even angle, and so the rounding is kind of implied when you see a decimal on an angle. Not entirely, but kind of. All right, good. Any other questions on those? All right, the other part of your homework was the 1319, the odd, where you were converting from the trig form back into standard, which is a lot more satisfying because your answer looks nice when you're done, as opposed to what we just did. And all of these happened to work out with special angles. Okay, we're going to take a look at one real quick after we're done that doesn't necessarily have the special angle. But we've got, for starters, 5 cosine 30 plus I times the sine of 30. And I mean, honestly, if I'd given you a problem like this last semester without any forewarning, and you just had to figure it out on your own, if you didn't give up, you'd have been like, well, I know what the cosine of 30 is. And I don't know what that I is doing, but whatever. I know what the sine of 30 is. And I know that when there's a number outside parentheses, you distribute it, so you probably would have figured out, Jamie.
It's 5 times 3 all over 2 plus 5I squared 2. I mean, just 2.
There we go. 5 squared root of 3 over 2 plus 5I over 2. Did we get that answer? Looking at the next one, we have the 8 times the cosine of 120 degrees plus I times the sine of 120 degrees. Now here, we have to think about the quadrant and the reference angle. We're in quadrant, which means when we find our reference angle, it's going to be 60 degrees. And we know the cosine of 60 is a half.
Yeah.
And the but in quadrant 2, cosine's negative. And then the sine of 60, and in quadrant 2, sine is positive. And then don't lose the I, right? And then we'll distribute the 8 all the way through to get and we'll sneak the I in between because we always put the radical last. So -4, positive 4I squared of 3. By the way, do you know what? Did I explain to you when you were younger why the radical always comes last? If you put the I after it, people would wonder, is the radical sign supposed to extend over it or not? If you're sloppy, so we just always put the radical last. There's no ambiguity here. The I is not part of the radical. It is part of the coefficient thereof. So anyway, did we get that for number 15? You did not question? All right, look at the next one. We've got the cosine 225 plus I sine 225, Jamie, quadrant.
The quadrant is the third.
Reference angle.
Oh wait. 45?
45.
Oh yeah, I have that.
What's the cosine of 45?
It's root 2 over 2.
All right, but in quadrant 3, cosines
Negative.
negative. All right, and we'll keep the I, actually I'm not going to put a plus yet, keep the I sine of 45.
It's root 2 over 2.
And it's a good thing I didn't keep the positive because in quadrant 3, sine is also
Negative.
negative. And we're going to distribute a 10 to all that.
So it's going to be negative 5 to root 2 plus negative 5I to the square root of 2.
There we go. In both cases, 2 and 10 cancel to give you 5s. Everything else remains. There's our answer for number 17. Good to go?
Yeah, signs are wrong.
Signs were wrong. Okay, question. All right. And then this one, there is no R value, right? It's an understood 1. No problem. Just roll with it, right? R value of 1. Cosine 315 plus I sine 315. Quinn, what do we need to do?
Reference angle is 45, quadrant is 4. The cosine of 45 is square root 2 of 2. That's positive. And then the sine of 45 is square root 2 of 2. That's negative. Then put your I in front of the yeah.
And we're done. There's nothing to distribute this time because the R was 1, so there it is. Do we have that for number 19?
Just the sign in the
Yeah, I'll read you later. All right, come on up. All right, let me give you a couple more to practice then. We feel like we're pretty good with this. 2 more to practice, and then we will take a quiz. All right, and let's do a 3 times the cosine of 200 plus I times the sine of 200. And let's do 16 times the cosine of 90 plus I times the sine of 90. All right, on the first one, 200 is not special, right? Its reference angle is 20 in quadrant 3. 20 is not special. Just distribute with your calculator. Here, we'll go give an extra decimal place because it's not an angle. So we'll say negative 2.82, negative 1.03i. Are we good to go on that one? And then on the next one, 90 is one of our special angles. We kind of think of it as quadrant 1. So what's the cosine of 90? What's the sine of 90? 1. So we're really doing 16 times 0 plus I times 1, or in other words,
16 times I plus 1, or
69. And there we go. Good to go on that. All right, go ahead and clear us, except for a clean sheet of paper, pencil, and a calculator. Clean sheet of paper, pencil, and calculator. Everything else away. First of all, let's name at the top of your paper along with today's date, which is 1/26/22. 1/26/22. All right, this is quiz 27. Quiz 27. should be fairly straightforward. Numbers 1 and 2, you got a couple of complex equations, solve for both x and y. Numbers 3 through 6, I want you to convert all of those into the trig form. And for 7 and 8, convert those back to the standard form. All right, any questions before we begin? All right, go ahead and get started on that. think that kid we've got locked in the cell downstairs is trying to drill his way out. If you're watching on YouTube, I'm kidding. We don't actually do that. Give drills to kids we've got locked up, I mean. We don't actually lock up kids, okay? Just in case there was a question. We don't lock them up. Unless they fail algebra quizzes. That's the only time.
Oh.
Should be finishing up in the next couple of minutes. About one more minute to be finishing. I'm going to collect those from you at this time. If you were going to take out your notes, and I told you that it's easier to do some things, and you can do more things with the trig form than the standard form. If that weren't true, there really would be no purpose in taking the time to figure out a trig form, frankly. Frankly, the addition and subtraction of standard form values is so easy, right? You add the reals, add the imaginaries, or you add the inverses. Super easy. But admittedly, the trig form, or the standard form multiplication with a FOIL, right? First, outer, inner, last, and then you got I squared created, becomes a -1, combining values. It's a little bit more involved to multiply standard form numbers. Where in the trig form, it becomes increasingly simple. You'll recall if we had something like a 4a squared times like a 2a to the 5th, or something like that. We said we'd multiply the coefficients, but we'd add the exponents, right? it's not terribly different to multiply complex numbers when they're in the trig form. 3 simple steps. Step number 1, multiply the r values. Multiply the r values. Just like you would have multiplied numerical coefficients in the past, this is kind of like that, I suppose. And 4 times 2 would again give you 8. The angle, you can kind of think of it like an exponent in the sense that we're going to add the theta values. Add the theta values. The book goes into kind of an explanation of how and why this works. For sake of time on the video, we won't. But just simply add. The 300 and the 30 gives 330. Plus I times the sine of 330. And just like that, we're technically done with the multiplication. Much simpler than in the standard form. The only last thing is I hate looking at the trig form, so I'm going to have us convert back to standard at the end. But the actual multiplication itself could not be easier, right? Multiply the r's, add the thetas, you're done with the main multiplication. Now we just got to convert it back to standard where we say, okay, well this is quadrant 4, reference angle 30. Let's see, cosine of 30, square root 3 over 2, and quadrant 4 cosines, positive. All right, sine of 30 is a half, and quadrant 4 sine is, and of course don't forget the I, right? And then we're going to multiply 8 by all of that to get
4 times square root 3 minus 4.
and we're done. Make sense? Let's do another one. Write this one down in your notes if you would, please. 4 times the cosine of 30 degrees plus I times the sine of 30 degrees times 7 times the cosine of 105 degrees plus I times the sine of 105 degrees. Now the previous problem, you'll notice both angles were special angles. If I'd wanted to, I could have converted them to standard. I could have FOILed, and I could have gotten that same answer that way. Here, it's going to be a royal mess to try to do that because we don't necessarily have both special angles. But we're going to follow the steps. We multiply the r values, class. We add the theta values to get cosine 135 plus I times the sine of 135. So even if you don't have special angles, even if they're weird, irrational values, you can still work with it easily enough in the trig form. Reference angle?
45.
What do you say?
45.
45. I thought I heard 35. I'm like, since when is that a special angle? Quadrant 2. And so the cosine of 45? Square root of 2 over 2, but cosine in quadrant 2 is negative. Sine of 45, and in quadrant 2, sine is positive. Don't lose the I. And distribute the 28 to get
Negative 14 square root 2 plus I, or 14 square root 2.
There we go. And there's our answer. Questions on that? To me, I feel like this is faster than FOIL. Maybe not a lot, but a little bit faster than FOIL. Agree or disagree? What do you think?
Agree.
You agree faster? Think faster? Okay. How about this one? 5 times the cosine of 115 degrees plus I times the sine of 115 degrees. The good thing is on quizzes and tests, it's already printed for you. You don't have to write out the problem. Isn't it great? All right. Unfortunately, this isn't printed for you. So 6 times the cosine of 65 degrees plus I times the sine of 65 degrees. Takes longer to write the problem than it does to work the problem. What do we do here, Jamie? First?
Apply the r's
To get?
30.
Then?
Add the degrees.
To get?
180.
So,
Cosine 180 degrees plus I sine 140 degrees.
and then to finish it out, we're going to convert it all to the,
Standard form.
recognizing that 180 has a reference angle of
0.
0. Right? You're measuring from 180 because it's considered either quadrant
1 or 4.
180
Oh.
is in either quadrant
1 or 2.
180.
2 or 3.
2 or 3, there we go. It's either quadrant 2 or 3, but how far, if you're in quadrant 2, you always measure from 180. If you're in quadrant 3, you measure from 180. How far from 180 is 180? Nothing, 0 degree reference angle. All right, so what's the cosine of 0?
1.
1. What's the sine of 0?
Doesn't matter.
0, right? So 0i. And when we distribute the 30, what do we end up with?
We'll get 30.
Correct.
Correct.
There's my answer. And notice that a couple of complex and weird complex as well. Those weren't special angles. Those are going to be very strange values. But you multiply them, comes to a whole, rational, real value. Write this one down. 3 times the cosine of 295 degrees plus I times the sine of 295 degrees times the cosine of 155 degrees plus I times the sine of 155 degrees. Make sure I've got all of that on the chalkboard there. All right, Quentin, what do we do first?
We'll put our values.
To get?
3.
Then,
Add the angles.
to get?
450
Oh, wait a second. Thoughts?
minus 360.
Yeah, anytime it's over 360, just subtract the 360 to get.
90.
So basically, cosine 90 plus I sine 90.
Okay.
Add the angles to get 450, subtract the 360 though, 90. What's the cosine of 90?
Zero over 1.
All right, and then the sine of 90,
1 over 1.
and don't lose the I, we'll distribute the 3, and we get 3i. And there we go. This time, a couple of rather strange complex values ends up yielding an imaginary value. Questions on those? All right, well, we'll work more with these in our next lesson. We'll also talk about how to divide, and that's where you get a real advantage. No more multiply by the conjugate, and then also having to FOIL, and then having to reduce. Division is going to be much easier. We're going to do homework this evening, and we will progress tomorrow. Have a wonderful rest of your day. You are dismissed.